Welcome to section 5.5. Now let's get started on those Cornell notes, people.
Well, after that introduction, let's go ahead and get started. This is section 5.5, and we're going to be talking about the rational root theorem. Now, when you guys see the word root, really that is also a solution and also is called a zero of the function. So when you see any three of these words, they're all the same thing. The solution, the root, the zero. The reason they have different names is we're going to be looking for these in different contexts, and hence the different nomenclature for these, in other words, the different names for these. So let's take a look at finding our rational root. Now, our rational root is can be found, but we first want to take a look at all the possible rational roots. So you can see I've got this word possible highlighted for a reason. And I want you to take a look at the setup here for finding all the possible rational roots. First, take all the factors of your constant term over the factors of your leading coefficient. So what I want to do is take a look at these P's and Q's. Get those erased here for a second. And we want to take a look at the factor of the constant term. Well, that's 5 right here. That's going to be labeled P. And our Q's is going to be the leading coefficient. That's going to be our Q right here. So we do have to watch our P's and Q's. So I'm going to list all the factors of 5 up here, 1 and 5. But remember, positive 1 times positive 5 are factors, but so is negative 1 and negative 5. Those are also two factors of positive 5. And I'm going to put those all over the factors of our leading coefficient. So what are the factors of 2? They're going to be 2 and 1. But remember, those are going to be plus and minus also. So the kicker here is that you want to set up all of the possible rational roots by taking 1 over 2, 1 over 1, and 5 over 2, and 5 over 1. Just like they did here. 1 over 1, 5 over 1, 1 over 2, and 5 over 2. So here are all of the possible rational roots. Now if you remember, when we plug in all of these roots, it's nice to see one spit out a 0. So let's take a look at what happens when you plug it into this function up here. The table is down here. So I plug in 1, spits out an 8. Negative 1 spits out a 0. 5, 240, negative 5, negative 280, and so on. And we can see that negative 1 is an actual rational root. So let's move down to this idea where it says possible. I mean possible because we're listing all the just possible rational roots. All of these are just the possible rational roots. However, when you plug it in, that's when you determine whether or not they're actual rational roots. So what did we just find? That's right, we found the possible rational roots. The possible rational roots. That's right, the possible rational roots. So let's take a look at finding the possible rational roots here. Now the book does kind of a snotty thing and they say, what are the rational roots? But really what we need to look for is the possible rational roots first. So I'm going to put all of my factors of my constant, which is 8. So I'm going to have 1, 2, 4, and 8. And again, all of those are going to be pluses and minuses. And then all the factors of 3, plus and minus 3. So let's list these all out. 1 over 3, 2 over 3, by the way, we've got to put a 1 here, 2 over 3, 4 over 3, and 8 over 3, Now 1 over 1, 2 over 1, 4 over 1, 8 over 1, those are all real easy. So if you think about it, here they are. All of these are pluses and minuses. And if I were to write these out in a line, it would be 1/3, comma, 2/3, comma, 4/3, comma, 8/3, and so on. 1, 2, 4, and 8. Now, we have to plug all of these in to this function to see which one spits out an actual rational root. So on your calculator, if you could, go to y1 and plug in your function. So here we go. Now we're going to plug in all of our possible rational roots into L1. And just use the division sign for your fractions. Now the fun part is to remember to plug in the negatives also. Because these really are a plus and minus. Now go back to the home screen. And what you're going to want to do is you want to hit your stow button. Let's do this first. First, let's go to y1, because that's where we stored our function, vars, y-vars, enter, enter, parentheses, and then we're going to pull up L1, second, 1, close parentheses, and then stow or store the solutions into y2, or excuse me, L2. And here's what this says. Take the function in y1, plug in all the values that are in L1, and store the solutions into L2. Press enter, and you'll see a string of numbers. The best way to look at those solutions is to hit Stat, Edit, and scroll over to L2. And you can see right here that we've got a 0 at 2/3. Let's see if there are any other zeros. We're going to have to scroll down. I'm hoping your calculator is faster than mine. And it looks like those are the only, 2/3 is the only 0 of the function. So the actual rational root is 2/3. Okay, so now that we've been able to find all the possible rational roots and the actual rational roots with the calculator. Well, let's see what we do with those actual roots when we get to them to find the other roots. Let's take a look at this equation right here. They first want us to find the actual rational roots or possible rational roots first. So let's list all the possibles. Factors of 2, all over the factors of 15. And in our little string that we're going to be plugging into the calculator, since this is 1 on the bottom, we get 1 and 2. Those are real easy. And then 1/3, 1/5, 1/15. And then 2/3, 2/5, and 2/15. And we're going to plug all these into the calculator. I've gone ahead and plugged all these into the calculator, and you can see that in my Y screen I've got the function, and then in the L1, L2 screens I've got all the new values, and I've also calculated it. So the nice thing about the calculator is that if you have this one command, Y1 parentheses L1 parentheses store L2, it will keep doing that command, so you won't have to re-enter that while you're doing your homework. So it looks like we have a couple zeros right here. And so let's go to Stat Edit and see exactly where those are. At 2 and 1/3, so we know we've got 2 and 1/3, and let's see if there's any others here. Let's scroll down. Looks like we have one at -1/5 also. We needed 3, and we've got 3. So those are all of our rational roots. So now let's go back to our very first problem we had, where we found out that -1 actually was an actual root. Well, the trick, the idea now is, what do you do with that -1? Well, guess what? If it's a root, it's a solution, then it is a 0, and we can use those zeros for what? That's right, synthetic division. So I'm going to drag down all of these coefficients and synthetically divide. First one for free, multiply, add, multiply, add, multiply, then add. So we had better get a 0 here because this is an actual 0 of the function. So now we're stuck with this 2x squared minus 3x plus 5. We know that one of the zeros is going to be x plus 5, or excuse me, x plus 1. That's going to be one of the factors. Now I need to find out the other solutions. Well, I could probably find out what are some factors of positive 10 that add up to -3. I could probably factor this, but let's do a little bit of practice with the quadratic formula. -b plus or minus the square root of b squared minus 4ac, 4 times 2 times 5, all over 2a. This is going to be 9 minus 40, which is -31. So it's going to be plus or minus 3 plus or minus I radical 31, because we're going to kick our I out, all over 4. And these are our other two solutions. So we've got -1 and plus positive 3 plus or minus I radical 31, all over 4. So as soon as we find the actual rational roots, we can use them as synthetic divisors. And that's it. Find all the possibles, plug them into the calculator, see what the actuals are, then use the actual as a synthetic divisor to whittle down your polynomial to a quadratic, and solve from there. I'll see you guys tomorrow.
Good job on the Carnell notes, people.